Harrier prototypes are nearly ready to fly, so it was time to visit my good friend Joel Vlasov in the Netherlands. With his help, we want to do the first VTOL and STOL takeoffs. We started today with tidying up his wonderful workshop. What we are doing here? Cleaning! Cleaning! He's already starting.
Tomorrow, the welcome shot, right?
Yeah, it's a roof shot.
Glass fiber with wooden and lightweight. I think this is a good combination.
Okay, let's bring.
Dirty again.
Yeah. Okay. We started the day with laminating one wing and also drive to the local hobby store Wouters to get some missing parts.
To go in one.
What did you print here, Joel? What is this?
This is the inlet of the F-35. No, we are.
Now it was time to complete the first VTOL Harrier. Here the ESC is installed and soldered to the EDF power cables. Parallel, I was reinforcing the wingtip of the STOL Harrier. Here I cover the rovings with a tape to make it flat and smooth. In the later version there is already a 5mm carbon rod installed. This was laminated with 2 carbon rovings and the gap was filled with micro balloons, and now we press a paper tape on it to smoothen up the surface. What are you doing, guys?
We are fixing drum momentum.
Joel starting working?
Yeah, I learned it from René Rosentrack.
Joel was also printing a complete Harrier. Here we can see the wing with the outer wing nozzles moving. They are already coupled with the flight controller board. And this is the very first attempt for a vertical takeoff, but the jet is struggling cause the EDF doesn't have enough power. The Pegasus ducting, which is installed in a Harrier, needs a lot of input power. Also the EDF should work with some back pressure. Additional to this, the 3D printed parts from Joel were a little bit too heavy, so it was impossible to lift up this Harrier. But nevertheless, we could test the control system and also the reaction of all the leveling EDFs, and they work really nice. We won't give up and tested a lot of different settings, but at the end it was impossible to lift up vertical with this.
Pulse width. Yeah, pulse width is the safest way.
The next day started with programming the KK2 board. We used a special one which is flashed with a special software called OpenAero VTOL, and this we can adjust especially for our Harrier. After installing the cables for the ESCs and also the servos on the wingtips, we have to solder the BEC power supply cable to switch on all the electronics. Means it's a successful maiden, just to lift up.
If you take off with this on this one is rudder, yes.
Now Joel could start to set up axis by axis and learn the KK2 board for this Harrier. Front and back EDF for tilt were the first.
Oh, with the starting.
The EDF start leveling.
Okay, plus and minus. I have plus minus. we don't look at the transmitter at all. I only look, because we can reverse everything,
Yeah.
I only look what I see on the KK toolboard.
Sounds great.
This is perfect, but wrong. So I just put a Oh. Yeah,
The wrong direction.
yeah, wrong direction. Front one is wrong direction. Number 1 is the middle. And only just hold it. One by one.
Here we are using a 3S LiPo with 4200 milliamps to power up the EDF leveling system.
Los.
Next are the wingtip EDFs for the roll control. These are 30mm ones and got up to 250 grams of thrust. In between, the KK board shut off immediately with no reason. Later on we noticed that voltage shouldn't exceed 5.5 volts.
5.5, it can drop to 5.1. It should be fine. Yeah.
Too much power now. Never. You can't get enough. That's not what Jeremy Clarkson used to say, huh? He wants more power.
So we set it up the UBSC to 5 volts and go on with testing. Also the stabilization settings on the KK board were adapted. We are getting closer and closer to the right correction response from the motors. First
Yeah,
time the yaw servos are working.
The wrong direction though.
Adding yaw control was the last missing step. Joel is slightly getting happy with better and better results. Meanwhile, the resin from the wing lamination is cured and I remove the paper tapes. Okay.
Die geht bis 5.
Da alles zusammenkommt. 2,4.
Should we install extra tape?
Here I'm checking the CG of our first VTOL Harrier.
Move the lipo.
On the ground.
This Harrier is much more powerful and also more lightweight, so it was easy for him to lift off. Joel is very experienced in setting up VTOL airplanes, and here he is doing the last settings just by feel it with his fingers. And this was really a historical moment. Our 3D print Harrier lift off vertically on its own. On the rear you can see some lead installed. This simulates the vertical and horizontal stabilizer, so the Harrier already has his original takeoff weight. After every start we did final adjustments on the board, so we get more and more control over the Harrier. The main battery is a 6S Libo with 4000 milliamps and 65 C. We were super happy that the Harrier can also hover very close to the ground. This is normally very problematic because of the ground effect. With getting more control over the Harrier, Joel is going to more action and also climb to higher levels. At this moment this was the longest hover we ever had done, and now it is in the air for about 1 minute. At the first moment we thought that the KK board was shutting off again, but we mentioned that the main ESC was getting much too hot, and so he was saving himself and shut off, and that's also why the Harrier came down very parallel to the bottom, which saved him from major damages. These cracks in the fuselage could easily be repaired with some super glue. Here we can see the 200 amps APD ESC. In the later version it will have cooling ribs on both sides, so that the temperature stay much more low. We will also install it a way that it stays a little bit out of the fuselage, so that is air cooling also given while hovering. Next day we go on hovering in Joel's living room, and here we can see an interesting effect. When we try to lift off vertically from a very smooth surface, there was some sucking down effect on the Harrier, so that it needs much more power to lift off.
But then it's controlling on the back here.
And also here inside, with all these self-made turbulences, the Harrier stayed very stiff in the air. And right after we were super happy with the VTOL version, it was time to tune up the STOL one.
Yeah. Yeah, I see.
Right on the first start there was a problem with the main gear. It couldn't be retracted, so I had no chance to do a safety landing on the skids. I had to land on the wheels.
Oh.
The grass surface on this airfield was super soft, so the wheels sunk deep into the grass and there was a hard deceleration, too hard for the front gear, so it collapses.
Oh.
Weil das hatte ich bei der Su auch, dass das im Boden einrastet, dass das nur so geht.
So, ja.
So, reicht völlig aus. We figured out that the front gear suspension was too soft and also a stopper should be added. Luckily the super glue also was helping us to repair it quite fast.
Nee, maar dat is belangrijk, hè? En daar hebben ze het blok.
Beside the main gear, also the front gear retract doesn't work anymore, so we had to do the following flights with gear down. I took my time and did several approaches, and at the end it works fine. But the landing speed of the Harrier was still too high, so we decided to do the approach also with nozzles down. Flying at these super slow airspeeds is only possible by the help of a flight computer, like a gyro. I was testing this already in my last test video. This is how the last test flights were done. The fuselage is leveled and the nozzle is about 30 degrees down. This approach is done by much more angle of attack and thanks to the gyro still controllable. The sink rate is controlled just by working with the throttle.
It's starting to look really easy. You fly so slow, super slow.
But this was still too fast for the landing, and so we go on with setting up for slower and slower approaches. And this can go slower. I can go slower. I'm sure now I can go slower.
You know,
Shortly before tail slide, I can go.
when I'm happy because when my Harrier flew, the big one,
Yeah.
it came in like 150.
Yeah. Because I just put forward and it accelerates. It becomes stable in the air.
It's a really easy airplane. Easy to fly. Easy to fly. Hey, you got history again, huh? Short takeoff, short landing.
Also, the takeoff distance could be reduced to just some meters and was looking more and more in Harrier style. But it was still necessary to land exactly on the concrete because the grass was too soft and overload the gear. I had to work on the throttle curve to do this very accurate descent. Start.
42.
Oh. Okay, now come back please. After some trainings pattern, I was getting more and more familiar with this special Harrier approach techniques. With the correct throttle curve, it became possible to land the Harrier super precise just at the beginning of the concrete. Right after this milestone was done, it was time for some fun. Now we got a VTOL and a STOL version of the Harrier. And the final step is to combine both versions to have a real VTOL airplane. Thanks for watching, guys, from Ingmar, Joel, Ziggy and me. These were wonderful days and we came a big step closer to our all dream to build a VTOL Harrier, and see you in the next video. Bye bye!